Thanks everybody for coming. It was a great turnout. And today we're going to talk about all the different ways you can use Python with IRIS. And I thought this talk, actually, my colleague, Bob Kuszewski, thought this talk was necessary because there's a lot of different ways. There's actually 5 different ways you can use Python with IRIS, and it can be confusing. With power comes complexity. So we're going to dig into a little bit of that, a lot of that today. Also going to try to show you a little bit of my development environment and some of the ways I manage stuff with VS Code and ObjectScript code and Python code and IRIS and all those things all together. So hopefully you'll pick up some tips. We can talk about that stuff later too. And I'm skipping ahead in my talk. And we're going to have some fun and take some questions. So I'm product manager for the IRIS data platform. My area is developer experience, along with Bob. We work together on a lot of things. And I'll be speaking today and doing some demos, and Bob and Stefan will help me out with questions. So as I said, you may, if you're not intimately involved with development of the Python features, you may be a little confused about what you might want to use. And so this session is really designed to lay out all the different ways that you're able to use Python, when and why you should focus on certain ones for your particular use case, and then show you some demo code, just give you a little bit of a hands-on feel for how you write code in each one. And at the end of this, hopefully you'll have a much better idea of how to choose what your Python strategy is. A lot of people are here because they have Python in their future in some way, and also to help you get started really as fast as possible with that strategy. So first of all, let's start off. I won't spend a lot of time on this slide. I don't think we need this very much. As the years go on, Python is obviously winning the developer race for most popular language. We see it in, I always forget how to pronounce it, people. The people index, basically how often people search on Google for different languages. Python is #1. It's the #1 most wanted language on the latest Stack Overflow developer survey. And it is a little bit hard to read here, but that bottom chart on the right shows you the most popular languages reported on Stack Overflow by developers. Top 3 are all client-side, HTML, CSS, JavaScript, I believe. And then 4th is Python. So, in terms of real, serious languages, we like to say, Python is #1 above Java, C#, all those. So clearly, there's a workforce reason to have a Python strategy. Hire people, they're more likely to know Python, they're more likely to have better experience, be more proficient because they've probably had other jobs where they've used Python. Easier to spin up a Python team than an ObjectScript team, potentially. If you have ObjectScript people, they're probably really busy already. Ecosystem, obviously, we talked about that. Jeff talked about that this morning. The rich ecosystem of libraries that already do really important things in Python. Image processing, data science, ML, all kinds of things. If you want to do it, somebody else has probably already had that problem and probably has put a library out there that does it in Python. So we hope to leverage that. The InterSystems community has been one which has had to build a lot of their own tools over the decades, and we want to make that a thing of the past and have us, more fully embrace the larger developer community and all the things that they have to offer us. And then finally, simplicity. It's a great, if you're not a Python developer yet, you may not know this, but it's a really great language to learn, very easy, and it actually scales with your work. It doesn't top out. You can continue to love it as you get more advanced. And even for us on the development side, on the process of integrating it into the product, it was pretty simple as things go, because it was designed to be instead embedded and extended. And Python and ObjectScript have a lot of similarities, which really helped us make this embedded Python option a reality. Oh, could you start the timer? Thanks, it'll help me. So the 5 different ways you can use Python today are the first 2, the DB API and PyODBC, are basically relational, SQL-centric ways of using Python. You have your Python program, write SQL statements in your Python program, and it gets to IRIS via an XDBC driver, either ODBC or, actually ODBC or DB API. And that is a really common, popular, mainstream way of using Python in an application. Basically writing SQL statements and getting back the results of SQL queries. Obviously, that doesn't work for everything on IRIS because we have a multi-model architecture. Everything is not relational. So IRIS native is a way to get at the global structure directly from Python. And that's our third way of being able to use Python with IRIS. And number 4 is the Python gateway, which kind of reverses the communications paradigm. So in the first 3, you'll see that you use a driver, either a DB API driver, ODBC driver, or a native driver to call from your Python program into IRIS, into the IRIS kernel. Python gateway turns that around and says IRIS can call out to a Python program and do something, tell a Python program outside of its environment to do something and get results back. And then finally, there is embedded Python, which I want to say is our newest feature, but actually DB API is the absolute newest. But embedded Python is probably, the biggest impact. And that is, there's no arrow there because Python is directly in the kernel, sharing memory, working directly with data. And so that's the lowest latency option that you have. So those are the 5 things. So how do you decide which one is right for you? Well, I have a little story here. So the first user sort of persona we have here is the person who's writing a standard web application. This is pretty much traditional full stack development. All your data is relational, and so the database access is all about SQL calls. Maybe the SQL query is heavyweight or complex, and so the SQL may take a while to run, but you're going to get back a small piece of data at the end, either to display a form or something like that. You're not going to send back megabytes of data to the client side. On the other end of the spectrum is the person who has a very data-intensive Python application. What the Python application is doing, probably requires tens or hundreds of megabytes of data. Maybe you're running, NumPy computation, something like that, computing some kind of pricing algorithm or decision matrix, and you need everything to be screaming fast because there are hundreds of thousands of megabytes of data going back and forth, and it has to be low latency. So that's the person who really needs tight integration of Python with their data. And then finally, there's a special use case which is really unique to this community, which is you already have an ObjectScript application in place. It's probably many years old or decades old, and it's got all the idiosyncrasies that come with that kind of length of project. And you have new mandates, you have new features you want to build, and you'd like to sort of change that process and bring in new teams. And you'd like those teams to be working in Python because that's what you can get. And but you have to add those features to your existing application. It can't be a whole new greenfield development. It's got to be incremental. And so that's where I'm cutting to the chase here. That's where embedded Python would fall into place. So the answer for the people who are doing all relational and SQL calls, returning small amounts of information, is using either DB API or PyODBC, one of those relational methods where you're just basically, you're sticking to SQL. Data incentive, the key thing there is high amounts of data, low latency, and the program needs to be very close to the data. Then you want to be thinking about embedded Python as your strategy because, because you'll have access to all the Python libraries, plus you'll have no separation between the data and the code. You won't have to send that over a TCP/IP connection. And then finally, this unique hybrid sort of mode, you still want to probably be looking at embedded Python, but you want to be using the method of embedded Python, which extends ObjectScript to have Python methods. So I hope most people fall into one of those use cases, and if you don't, we'll talk about that in Q&A. And so hopefully that gives you a little bit of an overview of, how these features and technologies have been designed to meet various use cases. And now I'm going to just show some demo code about how some of these things work. So we're going to look at DB API, native API, and embedded Python. We're only doing 3 out of 5 because obviously DB API and PyODBC would look very similar, just different drivers. And I don't happen to have a Python gateway demo. Okay, so I'm jumping into VS Code here. And for those who aren't familiar, so since I'm doing demos, it really helps to isolate my demo code to a certain version of IRIS. And so I have everything containerized here. I have a Docker compose file, which, actually I'll start with a Docker file. I have a Docker file which tells me to grab IRIS version 2022.1.0.209 from our containers repository. And then I do some things to it. Basically, the important thing is here I'm going to install the right driver for what I'm doing, and then start up IRIS. So I'm going to VS. One nice thing about VS Code is I also have a Docker compose file which basically, runs the Docker file, but also says, okay, this is what you want to do with ports and some other little things which I won't get into. But Docker compose controls the Docker file. So I am going to select, right-click on Docker compose and say compose up, which is going to start up IRIS. I've already built this thing, so it starts up really fast. Don't have to download all of IRIS again. I did that right before we started. So in a couple seconds, I'm up and running. VS Code also has built-in, I don't know if it's built-in or not, but VS Code has a Docker support. And all my extensions to VS Code are listed here, along with built-in functionality. But the Docker extension lets me see what containers are running. And if you've worked with Docker, you will know how annoying it is to try to remember all the little commands and whether you put an S at the end of the word or not. Is it Docker container or Docker containers? That's why I just use the UI. It's much easier. I don't have to worry about that stuff. So I go over to this little Docker icon. It shows me this is in green, so the container started up properly and it's running. And so now I have an IRIS environment. And I also don't like to remember some other commands about how to attach my bash shell to there. So I'm just going to right-click on there, and I can attach a shell just like that. And here, down in my terminal window, let me open a different terminal window so you can see that. So on my local computer, I have this kind of prompt, basically my computer username and the directory I'm in, DB API. Over here on this terminal I attach to the Docker instance, I have a different directory here, /opt iris build, and on that computer I'm iris owner, or on that container. So you'll see that's how I know I'm in a different place. So by the way, all this code I'm going to show is on GitHub, and there are nice little README files which tell you how to run the commands, so you don't have to take any notes, and I'm going to refer to these. So I did Docker compose up, opened a bash shell on the container right here. I'm going to cd to opt iris build source. And now I have a little file here. I'll show you what that program looks like. This is a very simple program which is going to connect to Iris, obviously a Python program, and then run a few little simple queries. Create table query, insert some data into that table that we create, and then we're going to do a little select. And I'll run it and then go back over that code very quickly. So I'm going to use Python 3. Just type the name of the file. And success. So I will show you what we did. First thing we did was we created a table. This is obviously, our first use case. So anybody who has used Python and written SQL statements in it, this will be, crystal clear. No problem at all to get somebody started. Simple, very, standard create table statement. We threw in a variable here for the table name. That's the only thing that's a little bit tricky. And what are we doing? We're creating some properties, my varchar, my int, and my float. And then we close our cursor and commit that so that it'll be there. And then we come in here and we just do a little bit of tricky stuff where I won't get into, but we're going to insert, I think we're going to insert 10 rows. Yeah, for here. Here we do a for statement 10 times, so we're going to be inserting 10 rows into the table, and each row is going to have slightly different data. We insert this one string here. Every row has the same data in that myString field. Then we divide the row by 10, and then we multiply it by another number. So we get a little bit of different data, which you see down here. And you see it down there because at the end here, we just run a select star statement. So the demo is not very interesting on purpose because it's so standard and so simple that it shouldn't be a lot to explain. So now I'm going to switch. So that was DB API, which is designed to be very boring and simple. Now I'll switch over to the native API, which just quickly show you. Oh, I better stop my container first. Now I'll switch over to the native API and show you, a quick little code on how to work with globals. Okay, that's shut down. So now I have another directory with another Docker file here, which is going to fire up the same version of Iris, but in this case, I'm going to install the native driver instead of the DB API driver. And so I'll be just ready to go with that. Oh. What did I do? I think we're okay. Let's make sure by running the code. Okay, so same process here. I'm going to attach a shell to that service and open up my README again. I think I know what I'm going to do, but I'm just going to make sure. Python 3. Now we're going to do mindmap.py this time. Okay, so let's look at what we did. Let's minimize this. You can see the whole program here. Oh, by the way, can you see that? Is this text big enough?
It's a little bright in the room to see the...
Okay. Yeah, I can show another feature of our VS Code support. We have two InterSystems themes. I'll go from InterSystems default dark to InterSystems default light. Is that better? Yes. Okay. So we have two themes in VS Code for object script. Actually, that doesn't apply to Python here. But when you're doing object script coloring, you want to use one of the two InterSystems themes because they're specially designed for accessibility and object script code syntax highlighting. If you're working with Python, use any of the built-in VS Code themes. Just have fun with that. Okay, so this program, very simple program. I basically have two JSON objects here, sample map and sample child. One has ID 1, one has ID 2. And one has topic chicken, one has topic spicy wings, and sample child's parent is sample map. The parent is 001, sample map has no parent. So all we do here is create a connection to IRIS, and then run this, use this function write.json to put it in. So in write.json, obviously, we take the JSON and we translate it. We just basically grab every key and value out of the JSON. This is not generic JSON processing. And we just put it into the global. And I'll log into IRIS and show you what it looks like in there. Just to prove I really did this. Localhost. Go into where our globals, we want the right namespace here. And see down here, here's my mind map. Right down here. So we'll view that, and we have that data in there. So very, very simple example, but getting 3 demos into half an hour, not easy. Okay, so I'll shut that one down and we'll get to what we've all been waiting for, is embedded Python. Okay, same thing here. Let's find our Docker Compose file. So once again, embedded Python, no driver. It's embedded in the kernel. So that's a good thing. What's less good is that you have to worry more about Python library management. You have to make sure that Python is able to find the right libraries. So one thing we do in the Docker file here is set the Python path to where IRIS installs its Python libraries. And to make that connection make that connection work, you need to have an IRIS username and a password in environment variables in this case. So all that happens in the Docker file. This is all in the GitHub repo. So you can copy and build your own from there. So what am I going to remember what I'm going to do here? Are we still building? Okay, there we go. We're done now. Okay, so in this case, let's attach that shell again. So in this case, we're not going to use the Python command. We're going to use an IRIS Python command, which is basically the Python command with a little wrapper around it to make everything smoother with finding everything you need from the IRIS side. And Bob can tell you the actual details instead of my hand waving on the difference between the Python 3 command and IRIS Python. Come on. And this command does a lot of interesting things. I mean, this program does a lot of interesting things. So what I'm doing here is, one other thing I did in the script was I loaded in a data set from an open source data set from the Titanic passenger list, and we're just going to explore that data. One of the great things about Python, one of the reasons I think it became so popular is because of one library in particular, Pandas. And Pandas is a great library for data exploration, and which is why I think that data scientists picked up Python early on, even though you can use Python for anything. It first became really hot in the data science world, and Python lets you quickly and easily do so many exploratory things with your data that people have done for a long time, but they were a lot harder before Pandas came along. So let's dive into this program a little bit. So what we listed out here was, when we ran this program, we listed out the properties for data.titanic. Let's go in here and see what we did there. So I have my program here, embedded Python. Oh no, I ran explore.py. That's what we want to look at. So explore.py is pure Python. We started out here by defining our data set name, just a string, data.titanic. Sorry, all this help is popping up, which is great when you need it, but not when you're demoing. So basically, I'm calling one method with this string variable called getDataSetProperties. So I'm just going to jump up there by command clicking on the name of that method, and it gets me right up there. And this is basically this is the method that's going to write out those properties. And to do that, I'm going to use a SQL query from embedded Python, select top one star from the data set. And I just need one record because I'm going to basically just look at the metadata for that result. And now we're going to go in here and we're going to do some, get metadata for the columns, and we're going to list it out. And so very simple stuff. It's very nice to do it here instead of in object script all the time. So we basically execute the SQL query, we get back a result set. We're just going to look at the columns this time. And then we're going to iterate through those and print it out into a JSON object, or in this case, Python dictionary, which is almost the same. And then we just print it out and it looks like JSON. So we get this properties list. Stack smashing detected. That's because I didn't. Okay, we had a problem with the fair property, which I debugged a week ago, but forgot to change the code. The fair property was, what was the problem with the fair property? Oh, it was a currency field. Didn't like a currency field in this program, so I'm going to redo this with the survived column. Yeah. Okay. I won't do that. because this is the only part that breaks. So, well, maybe I will quick. Okay. I could have changed the version, which was already, I should have just changed the version, which was on the container. So this should build and start up really quick because it doesn't have to download IRIS again. It's just installing Python libraries. Okay, so we're going to go on. I'm going to talk a little bit about the code anyway. So what we're going to do next is do some of those descriptive statistics, which I said the pandas library was so great at. So what I'm going to show you in a second is we're going to run the explore, or we're going to use the explore function, which is the basis of being able to make histograms and pie charts for your data, depending on what type of column it is. If it's a numeric column, it's nice to see the spread of your data in a histogram. And if it's more like a cardinal value, like a string value with only 5 or 6 types, you might want to see that on a pie chart. Or if it's something like a Boolean value, pie chart would be good too. You can see the percentage easier in a pie chart. Okay. So doing that would require a ton of a huge amount of code if you wrote that all from scratch. But what we do in InterSystems, in our embedded Python implementation, is bring the result of a SQL query right into a data frame. So this is the key code here. At a certain point, we're going to say, okay, select the property name. In our case, that will be the survived property, number of people who survived the Titanic sinking from the data set. So select that property. And we're going to pull that into a data frame, and we're going to look at the values there. Okay, so now we're running here. Going to fire up a shell on that again. And we're going to get that explore. Okay, so that's the second part of this. IRIS Python explore. And here are the statistics for that survive column. And I'm going to bring that into a new window here. VS Code automatically recognizes its JSON data, but I'm going to indent it nicely. And so when you pull, this is, as I said, this is backed by that pandas library. When you pull data into a pandas data frame, it automatically gives you count, mean, standard deviation, min, 25, 50, 75, and max. Those are, the most generic, nice ways to look at the spread or the distribution of a range of values. What we did in this program is we added to it, if it was a numeric data set, we binned it into, I think, 10 different groups to get it ready for a histogram. So in this case, there were 891 values. The minimum was 0, the maximum was 1. So we're basically going to create bins in between those. And I wanted 10% of the data to be in each bin. So here we had a value basically 0 to 0.1, then 0.1 to 0.2. Actually, I spoke wrong. We don't want the same percentage data in each bin. We want the bins to be equal ranges. So basically we have 0 to 0.1, 0.1 to 0.2, 0.2 to 0.3. and so on. And what we get there is something that's very easy to put into a histogram chart. Now let me go back here, and all that code is shown in here. So you don't have time to get into that. I want to leave time for questions. But there's one more thing I want to show about embedded Python, which I'm not going to actually run it, but I'm going to show you the code, which is that final use case we talked about, which is the hybrid object script Python development. And so I'm going to just quickly show that we could have done that same thing inside an object script class. So you could have tagged a method, a class method or a method as language equals Python, and as Jeff showed earlier this morning, have your code right in there. In this case, I have to import IRIS, import pandas, and then here I have that same RS. I run a SQL query, and then I have that same data frame conversion method, which changes it into a pandas data frame. And so, you know, there are so many flexible ways of, you know, mixing and matching your Python development with IRIS available to you. Okay, so I'm going to switch back over. I don't know, I'm just going to summarize here. So we saw some DB ABI code there. And we talked about how that's really well suited to client applications or full stack applications, kind of your traditional web development scenario. And so with those use cases, you want to be probably in DB API or PyODBC. If your web application happens to use the native API, happens to use globals, then you want to use the native API. That's probably not very common, but that's a potential use case. If you're using a lot of SQL stored procedures or functions or triggers, you definitely want to be looking at embedded Python for the future of your application needs. And as I said, if you're augmenting existing IRIS classes, if you have that hybrid development mode, you're building on a legacy application, embedded Python is the place you have to be. There is no other option. At least for Python, for taking your development forward in Python. You can always take your development forward with ObjectScript. And in the case of interoperability, Python Gateway is probably what you want to be using, a technology called PEX. It's possible to do some things with embedded Python, but I think that's a lot less mature. You'd probably, if you were starting today, you'd probably want to be using Python Gateway strategy. And then finally, if you're solely manipulating globals, you have lots of options. Basically, you can do it anywhere except through, obviously, a relational API. You can't use globals in a relational API, but you could use embedded Python, native API, or Python Gateway for that. And which one you use would probably depend on how close you want the data to the code. So I hope that clarifies a little bit of the different ways we see you being able to use Python across the platform and gets you a little more comfortable with how you might do that. So here's the URL for the demo code. If you want to get that and some other useful links, if you get this presentation, sometimes a little bit hard to find the drivers, so I threw that in here and some other nice links which could get you started quickly. And so thanks. We have some other, before we take questions, I'd just like to mention that there are some other sessions today where you can learn some more about use cases and PEX and embedded Python in the Tech Exchange. And there's an embedded Python experience lab right after this, which hopefully you signed up for already, but I don't know if there are extra seats. You might want to check that out. Okay. And there's a session tomorrow on language SDKs, what's new and next. Okay, thank you. Okay, start here. Could you come to the microphone, if possible, or I could repeat your question.
I can do that.
Hi.
Am I on? Okay. So for the first example, the DB API, when you did the create table action, does that create a persistent storage class definition, or how is that? Where does that live in IRIS now?
Yeah.
In the database. So so then I can actually access that class file, and could I add additional methods?
Yeah, exactly, you got it. So whenever you run a SQL create statement, you're going to create a corresponding class, a persistent class. And then, so you could start with the SQL create, and then go in and work with the class then and add methods to it all you want. I saw a hand over here next.
On your third example, your executable is called IRIS Python. Was that an alias you created, or?
So the question was, what is IRIS Python? And I'm going to let Bob take that, because he'll do a much more accurate job of answering that.
This always comes up. So in the Linux environment, if you want to be able to import the IRIS kernel into your running Python process, that process now needs to be able to connect to the rest of IRIS, because it uses shared memory quite extensively between all the various IRIS processes. So what the IRIS Python program does is it is set GID to the right group so that you can actually do that. It also sets your Python path so it has some right information in it as well, but that's really easy to work around. In Raj's example, he didn't actually have to do that because he was actually running as IRIS user, so it didn't actually do anything in his example, but that's what the IRIS Python program is for in Linux.
And where do we get that?
It is installed with IRIS.
It's built in.
Yeah.
Okay.
Which version do you have embedded, and how do you deal with upgrading Python, and do you support virtual environments?
The question is, which version of Python is installed in the kit? Don't go away. Can you upgrade it, and do we support virtual environments? The virtual environments one is which, but you might as well answer the whole thing. While you're up.
Right. So obviously DB API, the native API, and the gateway, whichever version of Python 3 you want, will work. Embedded Python is obviously a little bit different. So with IRIS 2022.1 and 2021.2, the IRIS the Python version that's supported with embedded Python is the default version of IRIS that comes with your operating system, except for Windows, where we install it with IRIS. And the reason for that is when you have multiple versions installed, we weren't really sure what to link against, the 3.6 client, or the 3.6 CPython, or the 3.8 CPython, and those sorts of things. So if you're running, I don't know, Red Hat 7, I think it's 3.6 or 3.7 that comes with Red Hat 7 now, whereas if you're running Ubuntu 22.04, well, we haven't officially released that support yet. If you're running Ubuntu 20.04, then it's 3.9, something like that. We are aware that different customers have different needs, and so we want to have the ability to support a wider range of Python versions with embedded Python. It's just not ready yet. What was the rest of the question? I'm sorry.
The virtual environment situation with embedded Python. Obviously, with the other ways, you can use virtual environments all you want. It's not complicated, but with embedded Python, it gets tricky, right?
Right. So you could use virtual environments and then just call IRIS Python. I do have a document I wrote up on exactly how to do that step by step. But again, the Python version you cannot change. So the only thing you'd get out of virtual environments is being able to better manage your package dependencies, which is still really critical, right? Other questions?
There's
Yes.
one over here.
Any plans to move the rule engine and also the data translation?
Can you use the mic, or I have somebody relay? I'm sorry, I can't hear.
Did somebody turn it off?
Oh, the mic's not working. Let's see.
Yeah, any plans to move the rules engine and data translation into Python?
No.
The DTL and
There's actually, is Guillaume here? There's some interesting things on the Open Exchange. So the Python support has created a lot of interest in taking a lot of existing technology and porting that into Python. So it's certainly possible. I don't think there are no official product plans to do that. Yeah, but Guillaume Rangier has something on Open Exchange which lets you do interoperability, business operations in Python, pure Python implementation of the interoperability stuff. But there's some things in the open source developer community right now.
Guillaume is showing a demo in the
Yeah.
Tech Exchange of what he's been kind of playing with, yeah. Anything else? You're all clear about when to use Python, the various Python clients, when to use embedded? Cool.
Great. Well,
Thanks, Raj.
thanks for coming. See you around.